Hey guys, what's up? Back at you here with day 14. Today we're going to talk about the quotient rule. The product rule had to do with the multiplication of two functions when you're doing the derivative. The quotient rule has to do with the division of two functions, obviously the quotient of those two functions. So let's take a look at the rule and talk about, look at some examples and we'll be done. First off, if we're doing the derivative of a function f of x divided by a function g of x, we have to follow this rule. And again, this rule needs to be memorized, just like the product rule needs to be memorized. It's always the derivative of the top. So in this case, that's f of x. It's the derivative of the top times the bottom function minus the top function times the derivative of the bottom. Now, so far, this looks exactly like the product rule. The one difference is we're subtracting instead of adding. Okay. And the last thing is this whole f prime g minus fg prime. The whole thing is divided by the bottom function, the whole bottom function, the whole denominator squared. By the way, just a little notation thing. Squaring the function g of x can also be written like this. Those mean the same thing. Okay, so usually to write it with a few less parentheses, a little bit simpler way to write it is g squared x. So let's take a look at a couple of examples here. Let's try this. F of x equals the natural log of x divided by 2x cubed. Okay, and our goal here is to find f prime. Okay, so I'm going to start by taking the derivative of the top function. The derivative of natural log of x is 1 over x. And I'm going to multiply that by the bottom function. Again, it's not the bottom function squared, it's just the bottom function, 2x cubed. Minus the top function, natural log x, times the derivative of the bottom. The derivative of the bottom would be 6x squared. All divided by the bottom function squared. Now it's the entire 2x cubed that's being squared. And this answer we have right here is a correct final answer for our f prime of x. It, however, is not very simplified at all. So if this shows up on multiple choice, you'll never see this unsimplified as of a function showing up in your answer choices to select from. Okay. Also, if we needed to evaluate this thing, we might want to clean it up a little bit. Well, let's start looking at how we can simplify this final answer. First thing, when I look here, 1 over x times 2x cubed, that makes 2x cubed over x. What's going to happen is this x is going to cancel out with one of the three x's that we have on top to make 2x squared. Okay? I can't simplify anything over here other than I'm just going to write 6x squared ln x. I'm going to write my polynomial first and my natural log second. The bottom then, 2x cubed squared. That literally means 2x cubed times 2x cubed. So I'm going to square that 2 and get 4. And I know a power to a power, I multiply those exponents. So this means 4x to the 6th. And what I'm looking for now is more simplifications that I can make. I notice that I have coefficients of 2, 6, and 4. All three of those coefficients are divisible by 2. I also have an x squared, an x squared, and an x to the 6th. So here's what I can do. I can divide each term by x squared. That will totally cancel out this x squared and this x squared, and it'll change this x to the 6th to x to the 4th. So I get a final answer then that 2 divided by 2 is going to become a 1. That 6 divided by 2 is going to become a 3. That 4 divided by 2 is going to become a 2. So I'm left with 1 minus 3 ln x over 2x to the 4th. And that's what would show up in the multiple choice if this was a multiple choice question. Okay, let's try one more. Y equals, let's do 4x cubed over cosine x. And our goal here is to find dy dx. Well, dy dx will equal, I'll do the derivative of the top function, that's 12x squared times the bottom, which is cosine x, minus the top function, which is 4x cubed, times the derivative of the bottom, which is negative sine x. Now, here's an important part. We are multiplying by negative sine x. It is really important here that you do one of two things. Okay? You either need to put parentheses to show that we're multiplying, or you can see that, okay, multiplying by a negative number here, it's going to change that minus sign in front of the 4x cubed to a plus. What I don't want you to do is write exactly what I wrote without those parentheses, because then it looks like you're subtracting sine x. You're not subtracting sine x. You're multiplying by negative sine x. All divided by the bottom function squared, so cosine squared x. And again, cleaning this up, I definitely don't want to leave this here. I'm going to be left with dy dx equals 12x squared cosine x plus 4x cubed sine x, all divided by cosine squared x. And again, I'm going to look to see if I can simplify anything. I have coefficients of 12, 4, and 1, so their greatest common divisor is 1, so that doesn't do anything. I see two cosines, but I can't cancel those out because there's not a cosine in this second term over here. And I can't cancel out any x's because there are only x's in right here and right here. There's no x down here. So that's as simplified as I can make it. All right, that's it for the quotient rule, and I will see you guys tomorrow. Bye.